Welcome back. Let's do example 3. Percy takes out a loan of 1.5 million to start a business. He is prepared to pay 159,828 every 6 months. The repayment starts 6 months after the loan is taken, and the bank charges an interest rate of 8% per annum compounded semi-annually on the outstanding balance of the loan. Determine the number of payments of full installments. I want to explain this point. I think I did not emphasize this from the beginning. The repayment starts 6 months after the loan is taken. But you have to know that in general, loan repayments start at the end of the first period after the loan is taken. What do I mean by that? Let's say now you take a loan here at the beginning of, say, January. Right, you take a loan, that's your present value, that's where your present value is. Let's call it T0 there. Okay, when do you start paying for it? You cannot take a loan here at the beginning of January and then you start paying for it there and there. Okay, so generally you take the loan and then after 1 month, then that's when you start paying, if it is monthly, because it can be semi-annually. Like in this case, he's going to repay every 6 months. In general, loan repayments start at the end of the first period after the loan is taken. So that's when it's going to start. Okay, and then after that, the payments are done till the loan is amortized. So in this situation, Percy is going to pay every 6 months. This will be the first 6 months. After 6 months, then he starts paying. After another 6 months, he pays like that. The other one I want to explain, it says, determine the number of payments of full installments. Let's say we calculate our n and find that n is equal to 2.5. These are number of payments. So it means here, how many payments are going to be done when it's like this? 3 payments are going to be done, but 2 payments are going to be for full installments, and then the last payment is when you're going to pay a smaller amount. But we're going to do this concept later. Okay, after present value, we're going to look at the outstanding balance and then deferred payments, and then we're going to look at these situations where the last installment is smaller than the other regular payments. Let's leave it for now and then we answer this question. The loan amount is 1.5 million, and then X is 159,828 every 6 months. We want to find the number of payments. Okay, the interest rate is 8% per annum compounded semi-annually. We're using the formula P is equal to X, then 1 minus 1 plus I to the power negative N, all this over I. Then we substitute. P is 1.5 million, so we write it there, is equal to X is 159,828, then 1 minus 1 plus 0.08, that is 8%, so it's 0.08, compounded semi-annually, so it's 2 times. We divide by 2 because it's 2 times in a year, and then in 6 months, it's going to be what? We're finding the number of payments, so let's find N here. We're finding the number of payments. Okay, so every year, 2 times. That's what we're looking for there, over 0.08 over 2, like that. And then what do? We can do things differently. Some people can say this divided by this, but I prefer multiplying this amount, the p value, with this 0.08 over 2, like that. So you say 1,500,000 times 0.08 divided by 2, you get 60,000, right, is equal to 159,828. Then the brackets, we have 1 minus 1 plus 0.08 over 2 to the power negative n, like that. And then now we can divide both sides by 159,828. If you say 60 divided by this, you get what? 0.37540355588, like that, is equal to 1 minus, then we can find this. Put this in the calculator as it is. 1 plus 0.08 over 2, you must get 26 over 25. And then to the power negative n, like that. Then subtract 1 from both sides of the equation. If you subtract 1 from both sides of the equation, you'll get 8,319 over 13,319. If you prefer to use decimals, don't round off. Don't round off during calculations. Then is equal to 26 over 25 to the power negative n. Now we can change this from exponential form to logarithmic form. The exponent becomes the subject, negative n. This is the base, so it's log 26 over 25, and then the argument 8319, then 13319, like that. Then you can put this in the calculator. It's very simple. You get negative n is equal to negative 12, 0.00002484. Round it off to the whole number. N is equal to, after dividing by negative 1 there, n is equal to 12. So it means here there are 12 payments. 12 payments. If the question had said how many years, what will you say? It's going to be how many years? It's going to be 6 years. Remember, these payments are done every 6 months, so it means 2 times in a year. So you can say 12 divided by 2, you will get the number of years. Okay, and then this part also, this part, remember how you can use the calculator that does not have this function. If you don't have this function, what do? It will become log 8319 over 13319 divided by log 26 over 25, like that. You'll get the same answer.